Hi YouTube, so this is going to be a fun with electronics video. This is for the 555 timer, which is a little, you'll see it in a minute, 8-pin IC, integrated circuit. I'm not going to go into how it works. I'm not going to go into the calculations on how you set up the different frequencies for whether you want a short burst, long burst, timings and all that sort of thing. All I'm going to do is show you how to wire it together. The very basic on-off oscillator. So let's go. Now I've just quickly watched the video back and I kept saying ohm for capacitors. Have I got one here somewhere? I'll just use this one I was using. So capacitors are actually measured in microfarads. That's the little U and an F, not ohms. Ohms are resistors, which are these things. So there's your capacitor, and there's your resistor. The resistor resists current, and the capacitor holds current. So there's a little thing before you watch the actual video. Thanks. Okay, so from the first video, there is the voltage regulator. So we've got about 14 volts coming in, which is off this line. Down to the voltage regulator, through the voltage regulator, a couple of capacitors that smooth it out, and then that goes down to this 5 volts. So the 5 volts is across this red line here, so anything I connect into that is going to be 5 volts. The ground goes all the way across this black line, and what I've got it doing is just jumping across to this one, because these are two separate breadboards, but they stick together. So I've stuck this second breadboard on so I can show you the next experiment. That ground is going on this cable, which then goes down to this end, and we've got another black line here, which then goes up to this resistor and this LED. So if I connect the positive side of the LED into the 5 volts power, then what happens is you can see the LED comes on. See that? See? It comes on and it goes off. And it goes on, and it goes off, and I'm going to stop. Okay, so this video is about the 555 timer. That's this little thing here. So it's got 8 pins on it. Now I'm not going to go into you know, the workings of the insides and how the comparators and op amps and everything inside works. This is going to be just simply how to wire it together so you can get signals out of it, and then you can then play with changing the components just to see what you can do with it. So as I say, it's got 8 pins. This one's got a little dot to say pin 1 there. So 1, 2, 3, 3 is the output. So I'm just going to connect the LED into the output. There you go. So that's in. I'm going to put my glasses on because I'm going blind. And it's dark in here, and I can't turn my lamp on because it interferes with the camera. The lamp is at the same frequency that the camera's refreshing at, so I end up with a flickery picture. Okay, so it's really simple. All we need to do is take 2 resistors, and how did I do that? Have I got the wrong resistors here? So that's that resistor. Now you always check, that's the ones, right, so I had the wrong resistors, there we go. So always make sure you've got the right stuff before you plug it in, otherwise you could blow things up and then end up wasting money. So just going to cut off the resistor and bend it a little bit so it goes into the breadboard nicely. So there's the, where is it, if you can see that, I've just cut it off so that the length is the same, and then just rounded the end off. So let's plug the positive in. So we've got some positive current going through. So positive goes to pin 8. So I'll plug it into pin 8 and then the positive into the positive. And as you saw, the LED just lit up there because we've got a positive going all the way through here. But now, if you don't know about breadboards, I'll just point out exactly how they work. They're really simple. As I say, the lines going up the sides here is what I was said about, which is the black line going up. All of the dots along that line is the same connection. With the red, all the dots going up there is the same connection. With the actual tracks themselves, it's where the breaks are across there. That's a separation between these 4 different pads, and then the dots joining between the breaks are all the same, you see. So I've connected to pin 8 there, and that's actually going up to here where I've connected the positive wire. And you see here on pin 3 where I've got the output. Well, I could take that to any dot in that row, you see, and it still works because they're all connected. I just chose to plug it into one right next to it, but you can plug it into any of them because they're all connected. They don't go this way, they only go up and down towards the break. Okay, so that way in the future, when you start to get more things like these other flip-flop circuits and the 7-segment displays, which have got the same pins on, you can plug them in like that, and then there you go, and then you can work on the pins, and you know that you're not gonna. But if you were to take one of these things, if I can get it back out, and put it this way round, you see, like that, what you've done there is if you've just connected every single pin on that side, because the pins go down the sides there, you've just connected every single pin along there, so not a good idea, because obviously that's just going to short everything out. Okay, back to where we were. So yeah, 2 resistors. Now you have a resistor from pin 8 to pin 7, so that's the positive there, so let's just put that in then. Actually put it around the other way so it doesn't touch. So pin 8 to pin 7, so that goes from the positive feed to what's called the discharge pin, and then the same again from pin 6 to pin 7. So we'll just put that in, and that's the threshold. Now again, I'm not going to go into how this works at the moment unless somebody asks, and then I can give you an explanation. But at the moment this is just wiring it together so you can see it working. Okay, now let's get some more wires. So we only need 2 more wires and we've got this thing going. So pin number 4 we want to put to the positive, and then that's the reset, so that tells it we're good to go, and in it goes. Another wire, and then we need to connect the trigger at pin 2 to the threshold pin at pin 6, but let's just get that there, so it's 5 and 6. So threshold and trigger, they touch together, and that's pin 2. There we go. So that's 5 and 6 connected together. Now what we haven't connected yet is the ground, so let's just get another cable and plug the ground in, but it won't actually do anything until we get a capacitor connected. So the way that this works is basically it charges up the capacitor. The capacitor gets to a certain voltage, and then that triggers the flip-flop circuit to flip, and that turns the LED on. Then it starts discharging the capacitor because it's flipped the circuit, and then when it gets down to below a certain voltage, it then flips the LED back on, and then it starts charging again, and then that's it. That's your flip-flop, and that's your back and forth. So the only thing left to connect is between the ground and the trigger and threshold, which are connected together. So all I have to do is take this capacitor. Now this is so let me just tell you what I've got here. So this is a 555 timer, as we know. These two are 10k resistors, but they could be less than that, they could be more. There is a calculation to determine how quickly this is going to run. Now this is a 1000 microfarad capacitor, which is a bit large, but, and remember, it's got the, let me just get it here, it's got the negative stripe. So what you need to remember is that the negative goes to ground, and ground on this one is pin 1. So we go from ground to pin 2, which is the trigger, and we've got a flashing light. Can you see this here? This flash on, off, on, off, on, off, on, off, on, off, and that's it. There you go. That's the 555 timer. Now, there's PDFs, there's data sheets, there's all sorts, to tell you exactly how it works. There's calculations of how you times the resistance by the capacitance to tell you how quickly this will actually trigger. But no, this is just simply how do you put one together, how do you make it work. This is how you put one together and make it work. I can chuck in another capacitor so you can see the difference. That's 1000 ohm. Let me get out 100. Let me just go in my box of things. So what we got here? So I should really put my glasses back on so I can see what I'm doing. These are 220s, so I think the 10s. What I need to do is label all my boxes so I know what's in what. Here we go. So these are the 100s. Now the problem is with the negative pins. Where's the camera? There we go. With the negative pins, they're always shorter, which is a bugger for breadboards. So you always have to cut them. So remember to always cut the pins, otherwise you're going to have wonky capacitors. So we'll take out the 1000 ohm, and we get so you can see the flashing. So we take out the 1000 ohm, and we will stick in the 100 ohm. So in theory, the charge and discharge is 10 times faster. So that flicking, and there you go. If it's picking it up on the camera, that is of course, it's actually flicking 10 times faster than it was before. And again, if I swap it out for a 10 ohm capacitor, it will be 10 times that. So because it's all about the calculation and your times in it. So let's see, should be in this box. Oh right, there's the 10 ohms. Yeah. So here's a 10 ohm capacitor. Now when dealing with capacitors, always make sure that your capacitor can hold more voltage than you're planning to put through it. Otherwise you could, well, you will blow them up. They don't really go over their threshold. If they say it's 25 volts, then it's 25 volts. These are all 50 volts, so I'm not worried at all, because I know that it's only a 5. Now that seems to be on, but if we stuck that on an oscilloscope, we'd be able to see that that's actually going on and off at probably about 1,000th of a second. On off, on off, on off, on off. Too fast to see. So I wasted time putting that on there. I'll stick the 1000 one back on. So now you can put an extra resistor in series to make it take longer to charge, or take less time to charge. But as I say, there are data sheets. Check the data sheets, and that's the best thing to do. Google it. Google is your friend, and it will tell you all these different things. But there you go, the 5x5 timer. Thanks for watching.